I think my mic is working now. That was weird. OBS deselected the mic. But anyways, sorry for the late start. You know, I had life stuff and then I had a late dinner. But in return, I'm gonna go through this, which is a very famous website's review of, well, they're a very famous website and they're known for helping practice for IB tests. And I'm just going to call it Training Town. So close to the exams for each year, they gather some experts who mark these exams and they collaborate and create what they think is what the upcoming paper, what it might look like. So a predicted paper. But I don't want them to like flag me or anything, so I'm just gonna call it Training Town and hope that I get away with it. And yeah, so I think everything's good now. Sound is good? Okay. Hello, Serpent. Yeah. And what's good is if you are in my class, you are now able to do most of these questions, I would say. So here's the first one. We got triangle, and then angle BAC is an acute angle, and then sine BAC. So the sine of this angle is 4/5. Find the area. Okay. Easy enough to do, right? Area of a triangle, 1/2 times 7 times 5 times sine of angle BAC. And then, well, 7 times 5 is 35. And then over 2. And then they told us what sine BAC is. It's 4/5. And so, what is this going to become? So 2 will divide into 4, 5 will divide into 35. So the area of this triangle is 14 units squared. Then we want to find cosine BAC. So because we know what sine is, and we know that this is in the first quadrant, so here's your angle as a right triangle. And it says that the opposite length divided by the hypotenuse length. So we can give these lengths of 4 and 5, which means that your adjacent is 3. Yo, Ace, how's it going? And from there, we can say that cosine is 3/5. Then we need to find the length BC. So we do have a cosine law set up. It's a little unconventional because we don't know the angle, but we know the cosine of the angle, which is actually the thing that we need. So BC squared is equal to 7 squared plus 5 squared minus 2 times 7 times 5 cosine BAC. And then we can just go through with all of this. 49, 25, and then we have 2 times 7, which is 14, times 5, times cosine, which we found out in the previous question was 3/5. Yeah, my sound is working now. Under the microphone settings, it deselected my microphone. And then because it's a paper 1, we just got to do this manually. So this 5 will divide with that 5. And then I have 49 plus 25, which is what, 74? And then 14 times 3, 42. And then 74 minus 42 is 32. So then BC is the square root of 32. Nice. So again, a little unconventional. Because I guess a lot of students would focus on trying to figure out this angle or knowing the angle. But what was really more important is the sine of the angle, which we used in the area formula, and then the cosine of the angle, which we use in the cosine law. Okay, now here's one that my students who are watching should be able to do because it's related to what they've been learning. Although, let's see if I can... And that's all the space I got. So we have two events, A and B. Probability of A is 50%, and then the probability of A and B is 0.1. And then you need to find various things. So like I recommend, we should draw a Venn diagram. And it says that the probability of their intersection is 0.1. So this is 0.1. And then it also tells you that this is 0.5. So this entire circle is 0.5, which means that this section needs to be 0.4. And that's all I can really fill out for now. Now let's see if we can answer the first question, which says, what's the probability of A intersection not B? And that's this number right here, right? This is the event A and not B. So this number is A but not B, or and not B. So I guess I found out part A without even knowing it. Okay, then they tell me that the probability of not A and not B is 0.2. So in your diagram, think about where not A and not B, what region this is. So not A, not B is this outside box. So this is 0.2. Now we can fill out this last section because if we're talking about probability, all the separate numbers need to add up to 1. So this needs to be a total of 1. So we can just take 1 and then we can subtract these three things, which is 0.7, I believe. So this is 0.3. Okay, and then what's a PAUB? Well, that is these two circles all together, which is 0.8. PB, and then this is a common mistake. PB is not 0.3. And I've seen it today in class with my students. PB is everything in B. So please don't forget the intersection as well. So overall, altogether, PB is 0.4. Okay, and then the last one is a conditional. So find the probability that it is A, given that we know it's not B. So we know it's not B, and I'm not going to use the formula. You can use the formula if you want to, because we actually have we don't have all the parts, but you can find all the parts to use the formula, but I'm just going to think about what it means, right? It is given that it's not B. Therefore, it is out of these two numbers. These two numbers are not B. So our probability is out of 0.6. Now, which one of these numbers is A? That's 0.4. So this is 0.4 out of 0.6, which you will lose marks if you leave decimals in a fraction. It's one or the other, so you can't be mixing them. This is 4 over 6, which is 2 over 3. And then see? Not too bad. As long as you understand what the heck all of these mean. Oh, maybe I'll stagger them. Time to run. Why are we running? Because you're here? Is that what you're trying to imply? Okay. So consider Consider 6CA, and then it becomes this formula. And then we need to find the value of A. Okay, so let's give this some thought. You can check your formula book, but if you have NCR, then this is the same as n factorial, and then r factorial, n minus r factorial. And then if you just compare the numbers, it's fairly clear that A has to be 2, because 4 is 6 minus 2, right? N minus r. So this number has to be 2. So A is 2. Then we need to determine the sum of the first 3 terms of this binomial in ascending powers of x, giving each term in its simplest form. Yeah, you should know how to do this. This is way back in topic 1. Binomial theorem. This is a binomial theorem question. So determine the sum of the first 3 terms. Okay, and we want this in ascending powers of x. So actually what I'm going to do is I'm going to rewrite this so that, I don't know, I'm just more comfortable with it this way. And then when I use binomial theorem, I will have ascending, actually wait, hold on, ascending powers. Whoops, never mind, ignore what I said. We want ascending powers, which means we start at the lowest and then we go higher. Okay. So the first term is 6c0, and then it's 1 to the power of 6, negative 3 to the power of 0, 6c1, 1 to the power of 5, negative 3x to the power of 1, I forgot the x on this one, and then 6c2 times 1 to the power of 4 times negative 3x to the power of 2. Okay, and then we will need to simplify this. So 6c0 is just 6. And you know what? Let's do this the fun way. Let's make Pascal's triangle so that we can find these coefficients. So we have 1, so this is the 0th row. And then we have 1, 1, so this is the first row. And then we need to go up to the 6th row. So 1, 2, 1. 1, 3, 3, 1. So this is second, this is third. 1, 4, 6, 4, 1. This is the fourth. I'm running out of room. 1, 5, 10, 10, 5, 1. So this is the fifth. Hey Tofu Char, how's your picnic earlier? And then the sixth row I'm gonna write over here. So it's gonna become 1, and then the next number is, I add the 2 diagonals, so 6, 15, 20, 15, 6, 1. Yeah, it's very hot out nowadays, which is kind of nice. Okay, so as you can see, 6c0 is 1, obviously. And then 6c1 is going to be 6. And then 6c2 is 15. Do you remember this now, Vincent? A little bit? Okay, so I'm going to write it in orange in this little corner. So I have, this is 1. And then, so 1 times 1 to the power 6 times negative 3x to the power 0, all of that is going to be 1. Okay, 6c1 is 6. And then these ones essentially don't matter, so we can just ignore them. So we have 6 times negative 3x to the power of 1. So this becomes minus 18x. Yeah, the formula thingy. Yeah, apparently you do need to know it, so we'll talk more about this later. And then 6c2 is 15. So this is 15 times essentially positive 9x squared. And then what the heck is 15 times 9? What's 9 plus 45? 135? So here are the first three terms of that binomial. Yeah, you might get sunburnt. Okay. So the next one is calculus. So, well, you either know it or you don't. So we have a function, and then we want to integrate it. And then if you look at this format, right, you have like x's multiplied by some other functions of x's. And at an SL level, the only thing you know how to do is do a u substitution for anything like this. So take a look at what you can do a u substitution of. If you took a u substitution of all of this stuff, 3x squared plus 1, notice that when you take the derivative of that, you get 6x. So that's a good sign. So we do a u sub. Which will clean everything up, essentially. So that integral becomes essentially just 1 over root u du. So this is just 2 root u if you take the integral plus a constant. So 2 3x squared plus 1 plus c. And then we want to find a definite integral, so we do know this part right here. So I essentially just plug in 4 and 1. So this becomes 2 times root 4 minus 2 times square root 1. So this is 2 times 2, which is 4, minus 2 times 1, which is 2, so 2. Easy peasy. That should be an easy 6 marks for those that know calculus. Okay, next up, function stuff. So this is topic 2. So here we have a function from -4 to 5. And then we want to write down the value of f of 1. Oh, that's an easy 1 marker. So when the x value is 1, find the y value. So right there is the x value of 1. So the y value at that coordinate is 0. Next up, we want to find the value of f of -2. So this is a composition. We need to find f of -2, which is the y value, and then we take that y value and then we plug it as an x value a second time and find a second y value. So where's f at -2? That's right here. So that's a y value of 4. So this is the same as saying find f of 4. So now we go and find the y value at 4, sorry, x value at 4, and we get a y value of -3. So f of -2 is -3. Then let's talk about inverse. I know that the inverse of some a value is -1, and then this is just testing your knowledge of inverse. Essentially, -1 is the x value, and they're asking you to find out what's the y value. So if I have an x value of -1, the y value is 2. So this is 2. A is 2. And then, given that g is -3 times f of x plus 1, find the domain and range of g. Okay. So g is a function transformation of f, and its domain and range are essentially the transformations of the domains and ranges of f. So let's write down the domain and range of f first. So domain was given to us, that was -4 to 5. And then our range is from also -4 to 5. Down here at -4, up here at 5. Okay, now let's check out our transformations. We have 2. Well, technically 3. We have a reflection. Across the x-axis. And then we also have a vertical stretch by 3. So these two transformations are going to affect my range. First, we flip it upside down. So then it's going to have a domain from -5 to +4. And then we vertically stretch it by 3. So then those extreme values get multiplied by 3. Hey, Snake Star, you want to tune in for this, because this is a very famous website's predicted paper. So I can't say the name. I'm going to call it TrainingTown. And before the exam every year, they gather experts that mark these exams, and then they ask for their opinion on what this year's exam will look like, and this is their prediction. So maybe you want to watch the old videos, or watch the VOD once it comes out. But anyways, I can't say what it is because, you know, I don't want to get like reported. But TrainingTown. Okay, what was I saying? I'm going to transform this, right? So I reflect it, so it goes from -5 to +4. And then you multiply it by 3. So the range of G is from -15 to +12. And then the other transformation we have is just the left translation by 1. So the domain of G just moves left 1 space, so it goes from -5 to 4. And then it's done. Okay, what's next? Solve this one. Okay, we want to show that this log is equal to this log. Okay. So we can work with both sides. It's essentially a little mini proof. So what I'm going to do is this square root I'm going to write as an exponent of 1/2. And then that means that using your log properties, we can write this 1/2 as a coefficient. So this becomes log 2, 3 minus cosine 2x over 2. Okay, and then on the other side, I'm actually going to leave it here, and then on the other side, notice that this is a log 4. Now, if I want to show that they're the same, I need to change this to log 2. So I'm going to do a change of base formula, or use the change of base formula to change the base of the log. So this, I'm going to change to log 2. And following that format, the denominator is log 2 of 4. And if you understand your logs, you know that log 2 of 4 is actually 2. So the left side is the same as the right side. Okay. Then, hence or otherwise, so hence implies that you're probably going to use this to help you solve this. We want to solve this equation for x being in the first quadrant. Okay, so as you can see, this first term, I don't think I can do anything with that one. Oh, I guess this term right here on the right side, I can change it into this using part A. And then I'll have matching logs. At least their bases are the same, which is a good start. So using part A, I'm going to change that to log base 4 of 3 minus cosine 2x. Okay, and then essentially we have a log equation, so I need to collect my logs together and then probably convert to exponential form. So let me just double check that I did this right. I changed this one, which is this, to this, and then I have the same bases. Okay, so let's collect our logs together. And then when we do, they're going to be subtracted from each other. So I can divide the inside of those logs. And then this is going to be equal to -1/4. So changing this to exponential form, this says that 4 to the power of 1/4, which is the reciprocal of the 4th root of 4, and this requires you a little bit of knowledge. Hopefully you guys know that the 4th root of 4 is the square root of 2, because root 2 times root 2 times root 2 times root 2 makes 4. Yeah, this question is quite complicated, but we're almost there. So this is equal to 3 sine x over 3 minus cosine 2x. Yeah, you should know this. Because 4, right, is split into 2 and 2 if you multiply them. And then if you split this into 4, it's root 2's. So the 4th root of 4 is square root 2. Man, and then they want you to keep going, I guess. Because you gotta solve for x, right? Yeah. Alright, so down in this denominator, we have a double angle. So we're going to use double angle identities here. And let's see, which one should we use? The numerator has a sine x, so I assume I'm going to use the double angle identity that has sine x in it. This is a brutal question, what the heck? Because, man, Okay, so you're gonna subtract the 1 and then you get 4, and then what the heck is this? So did I go wrong somewhere? Five marks. Brutal. Okay, change this one to that one. So I change it to that. Alright. You should watch this some other time then. Yeah. Good night, Snake Star. And then move this over here, so then it's gonna divide when you combine the logs. And then 1/4 negative over on the right side. So change this to an exponential. So 4 to the power negative 1/4, which is reciprocal, 4 to the 4, which is square root of 2. And then that's equal to this stuff. I mean, I guess you can cross multiply. So let's do that. So this is gonna multiply over here. This stuff is gonna multiply over here. I don't know. I'm just thinking out loud, but I feel like this might be it. And there's probably a more efficient way. Because this does not look nice at all. I mean, you technically have a quadratic, but I have no idea if this is factorable. I don't think it is because of this 3√2. Is this a calc question? No, these are all paper 1. Okay, I'm gonna try an alternate approach. So let's try an alternate approach. So I have log 4, and then I used part A to have log 4. Now, it'd be really nice if I had some common sense going on, and then, you know, I can just make, if I have one entire log 4 on this side, then I know that the inside is equal to this. So what I need to do is I need to change 1/4 into a log 4 statement. And that's easy enough to do because 1/4 is 4 to the power negative 1. So this is log base 4 Wait a minute, hold on. How does this work? Oh wait, hold on. Okay, forget the -1 thing. You just write it like this. Because this is essentially, you write it, you pretend that it's an exponent, because that's what logs are. So this will make more sense. For example, if you want to change 2 into a log base 2, you need to say that it's 4, right? Because the answer to this is the exponent of 2. So to change this into log base 4, then it's just 4 to the power of this thing. And then we know that this is root 2. And then now we can multiply these together, so it becomes 3 root 2 sine x. And then we can ignore the logs, and then we're back to this equation again. Okay, okay, fine. They want to play hard. I see. So the first way we did it was actually right. It's just I didn't think that they would make me do this, but okay, I guess they're gonna make me do this. So 2, use the identity. And then we are going to collect everything on one side. So yeah, we will have a quadratic. And then we need to solve this quadratic. I can't believe that this is only 5 marks. So is this even factorable in a nice way? I don't think so. So do you also need to use quadratic formula? That would be crazy. Do we do it? You have to do quadratic formula with a coefficient that's a radical? They are expecting too much out of you. This is a question you skip, hell yeah. But we might as well do it. And I might be wrong, you know? And maybe the answer key is going to show me a very elegant way to do this. This is like a super question. It has like 4 different topics in this. Okay, let's calculate this discriminant part. So 3 root 2 squared. So 3 squared is 9, root 2 squared is 2, so 9 times 2 is 18. And then 4 times 2 times negative 3 is 24, right? So what's 18 plus 24? 30, 42? Then 42 is 21 times 2. Okay, I messed up somewhere. So, I don't know. We're going to skip this one for now, and then I'll come back to it later. Okay, this is getting cramped, so I'm going to cut the next questions and then paste them on a new page. Okay. Ooh, stats question. We have a group of 10 office workers, and then this is how far they walk to work each day, the 10. And then find the mean distance in kilometers. Okay, why would they make you find the mean in a paper 1 question? That's stupid. Okay, add these all up. And then divide this by the 10 people. This is easy marks. It's just, why would they ask you to do this? Okay, I'm cheating. I don't want to waste time doing mental addition of decimals. Okay, and then I'll check the answer key, I guess, for the answer that the question I skipped. Now, I was warned by a student that this predicted exam is quite difficult. And I think they said that it's almost unreasonable. So 5.6. So your mean is 5.6. Okay. However, here we have a box and whisker plot, and they want you to find the value of p. So don't forget that the p, this number in a box and whisker plot represents the median. So what we need to do is we just need to find the middle number. And I'm just double checking that these are in order, because if they're not in order, that's really mean of them. Luckily it is. There's 10 people, so it is in between 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so it's in between 5.6 and 6. So that number, I think, is what, 5.8? 5.85? Right? Okay, let's count this out. So you have 5.6 and then you have 6. So, well, I guess, okay, this one is 6 and then this one's 5.6. So 5.7, 5.9, 5.8. Yeah, okay, it's 5.8. And then find the interquartile range. That's easy. You just do 7 minus 5, which is 2. Today I was teaching martial arts and one of the kids was like, wow, you can do 3 10 times 20. Oh, 3 divided by 10 times 20 plus 6 divided by 1 minus 3 or something. And I actually did it in my head. Wow. And he said the answer and they were like, wow. And I was like, yeah. I'm more surprised that they knew what the answer was. Anyways, okay, what's next? Find the distance less than a certain amount of kilometers is considered an outlier. So we want to find out how little you need to walk before you are no longer considered an outlier. So to find that, we take 5 and then we are going to subtract 1.5 times the interquartile range. Now 1.5 times 2 is 3, so 5 minus 3 is 2. So if you walk less than 2 kilometers, then you are considered an outlier. See, this is all stuff that you guys can do. Okay, and then it says here 20 freelancers recorded their distance and they walked on Monday. Okay, the mean of this distance walked by this group is 1.7 and it has a standard deviation of 1. Find the total distance the group of freelancers walked around on Monday. Okay, that's easy. We know the mean is 1.7, so if we just multiply this by the 20 freelancers, then we get the total distance they walked, which is going to be, what's 17 times 2? 34? So there's the total distance. Okay, then find the combined mean distance that all 30 workers and freelancers walked on Monday. Okay, so now we're combining these people with the first people. So the first people walked a total distance of 56. So 56 plus 34 is 90. And now there are 30 people, so their average is now 3. Okay. Then on Tuesday, the 20 freelancers walked double the distance. Calculate the variance walked by the freelancers. Okay, so their new standard deviation is twice the old standard deviation, so it's 2 times 1. And then the new variance is the square of the new standard deviation. So 2 squared is 4. See? Not bad. Pretty doable question. Okay. Let me see if I can... I'm gonna go check out that answer key real quick. But first I need to log in. Off screen. And then I'm gonna look at the answer key. And then I'm gonna show you the answer key, but I'm gonna be careful not to show you any logos of this very famous website. A website that will go by the name TrainingTown. Oh my lord. Okay. So let me just double check what's happening here. Oh, I messed up. Okay, guys. So this question, let's recap. There were 2 ways that we got to this equation, and then I messed up the equation because this should have been 2, and this actually lets this be doable. And this is what you're actually supposed to do. This is a crazy question. So first off, you need to somehow get to this quadratic here. And I showed you 2 ways. And then this quadratic you can't factor, so you are supposed to use the quadratic formula. It's just I messed up the quadratic formula because this should have been this, which was minus 2. So then we have 18 plus 16. 18 plus 16. What's 18 plus 16? 34? That doesn't work out. I messed up still somewhere. Oh my gosh. Okay, this should have been plus, which means that the quadratic should look like this instead. Oops, I forgot. This is minus minus. And then that changes things a little bit, because this is now negative and negative, which is positive. I'm not gonna, I guess I'll write the negative in here. It's not gonna matter because I'm gonna square it. And then this negative doesn't work anymore. Okay, so let's go through this. This is actually what you're supposed to do. use log rules, combine your logs, then use trig identities here to change it to a quadratic, and then use quadratic formula with a radical coefficient, which is crazy, and then you get so far up to here. Okay, so 3 root 2 squared is 18. 18, and then 4 times 2 times 2 is 16. So 18 minus 16 is root 2. There we go. Okay, and then negative 3 root 2 plus or minus root 2. This is either going to become negative 4 root 2 over 4, which reduces to negative root 2. Or if you add the root 2, this becomes negative 2 root 2 over 4, which reduces to root 2 over 2, which is the same as negative 1 over root 2. Okay, so these are your two equations for sine x. This first one has no solution because root 2 is greater than 1. Well, I mean, it's smaller than negative 1, so that's no solution. And then from here, sine x is equal to negative 1 over root 2, so it has a reference angle of pi over 4, and then it's negative, so then it is in, whichever quadrants are negative. Oh wait, it wants it for the first quadrant. Did I mess up somewhere? Because this isn't in the first quadrant. Yeah, there's more. We're at the end though. Did I mess up somewhere? Oh yeah. Oh, whoops. I forgot to change this. This should be positive. Okay. There we go. Okay. Okay. So this, I turned this one to positive, but I forgot to turn this one. So if you plus a root 2, you get 4 root 2's, which simplifies into a root 2. And then for the same reason as before, there's no solution for this. Sine x can't be greater than 1. And root 2 is greater than 1. And then from here, blah, 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 same thing. We subtract the root 2, so you get 2 root 2 over 4. That reduces to root 2 over 2, which is the same as 1 over root 2, which has a reference angle of pi over 4. But your angle is in quadrant 1, so therefore this is your answer. Wow, what a beast of a question. That is crazy. Log, trig, quadratics, and then back to trig. It's doable because you guys are listening to me explain it to you, and obviously you understand the steps. But that's very different than you being in the middle of a test and trying this out. I guarantee, I don't think anyone can do this in our class. Some of you might get kind of close, maybe. Maybe a few of the brighter students can get this far. But yeah. That's brutal. Absolutely brutal. It's one of those things that's so far out that, like, you can't tilt people because they're just gonna be like, oh, okay. Okay, let's try this one. You have parabola, and then you can draw a little box in the parabola, underneath the parabola, and in between the x-axis. Like, I could do it. It's just every step of the way I was doubting myself because I'm like, is this actually what I need to do? Because that's crazy. And it turns out that it was what you needed to do. Crazy. All right. So this is the rectangle, and then I need to show that this area is 32a minus 2a to the power 3, and then a is this distance right here. So notice that a can represent the x value for this coordinate. And then that's important because then that means that this height, which is the height of your box, is the y value of the coordinate d. And we do have the function for the parabola. So the y value is going to be 16 minus a squared. And then if that's the height of the box, and then you know that the total width is just 2a, then it's pretty clear that this is going to be your answer. So let's just write that out fully. So 2a times 16 minus a squared, and then that's going to turn into this. Does that apply in, that's normal in math? Yeah. I don't know. RGBT is just trolling, because his life is stressful. So this is how he takes out his stress. Okay. And then from here we move on to calculus. Hence, find the value of a being positive such that this area is a maximum. So this is your area formula, essentially. So let's call that a, big A. And to find a maximum, we're going to do some optimization. So we take the derivative. This becomes 32 minus 6a squared, and then to optimize this we set this equal to 0 and solve for 32. So in other words, a squared is going to be 32 over 6. This reduces, I guess. What does this reduce to? 16 over 3. So then a is root 16 over 3. That's not a nice number. I thought this would be a nice number. But okay, whatever. Okay, let this function be another parabola, and then show that when the graphs of f and g intersect, this needs to be equal to 0. Okay. So if they intersect, then we can just set the functions equal to each other. So f was 16 minus x squared, and then we can set this equal to the function g. And then if we just rearrange it, I'm sure we will get this. So let's just do that. Okay, let's see. So 16s are on both sides of the equation, so we can take them out. And then if we move this over here, then we have exactly what they wanted, I think. Okay. What if you don't come to class tomorrow? Then I mark you absent. Do you think it is safe for me to buy Timbits for the class? Probably not. What, you're not gonna show up to our last day together? Well, I normally do something on the last day, but it's normally food related. You already do too much for us? Yeah. You're gonna stay up studying? Oh right, you guys have your biology. We should go outside. I don't mind going outside. It's just there are people that don't want to, and then that's always a pain in the butt. Well, donuts are superior just based on the fact that there's more per unit. Okay, and then let's do this last one. F and G only intersect once, so that means that the discriminant of this quadratic needs to be equal to 0. So that's easy enough. Then we can find the value of k. So 8 squared minus 4 times a, which is 2, times c, which is k. And then k is not 0. I mean, you're actually not wrong if you had only put one exclamation mark. But you can tell from this equation, if you want this to be 0, k needs to be 1. Actually, no, it doesn't. What am I talking about? Needs to be 2, right? No. Shoot. Okay. This is 64. And then this is 8. Oh, what am I talking about? K needs to be 8. My bad. Because 8 times 8 would... yeah. Alright, this question wasn't that bad. I'm just a little wary about this answer. This is kind of ugly. And then, did I mess up? I'm going to check the answer key. No, I did not mess up. Sick. Okay, and then I'm actually at the end of the exam, I think. That was kind of quick. And unfortunately, like I started late today due to adulting reasons, and you know, I didn't have a chance to set up Minecraft, so no Minecraft today. I know you guys voted for it, but maybe on Sunday. But I don't know. This weekend's gonna be pretty busy, just because it is the end of our quarter. So I'm busy marking IAs and then getting your marks together for the report card. So maybe next week. But then next week is also the first week of the next quarter, which is also busy. So who knows? Yeah, I gotta mark IAs. It sucks. Do you get a 7? What are you talking about? Oh, for your report card? Can you have a 7? I don't know, is your average a 7? Yeah, well, adulting reasons, like, you guys know that I'm selling my place, which is why it got cleaned up. And we're in the process of purchasing a place. And then today we had to go out and then do some of that related stuff. What is the average of 4, 5, 6, and 7? That's statistics. You should be able to tell me. Yeah, give me them tendies. Okay, this one's a calculus one because I see derivative and stuff. So let's find the derivative of this function. Okay, that requires chain rule. But pretty easy if you know the process. And then hence, find this integral right here. Oh, and I forgot to subtract 1. And notice that this integral is exactly this. So I'm just missing that 3 over 2. So this integral is actually our original function. So x squared plus x to the power 3 over 2. But because we don't have this coefficient here, we need the reciprocal of that. So that when we take the derivative of this part, this 3 over 2 will multiply with this 2 over 3, and then we end up with nothing. Okay, and then consider the functions f, which is this line right here, g, which is this graph right here, for x's greater than 0. 5 is a great IB mark. Okay, then the shaded region S is this region. Write down an expression for the area of S. Okay, well, how much of an expression do they want? Because this is the integral from 0 to 2 of g of x minus f of x. And I don't know how to say that name, but thanks for the follow. NJNJBSRTT. I guess you could actually plug in the expressions of the functions themselves. So I feel like I should do that, because I'm probably going to need to do that for the next one. Whoa, this music got really loud all of a sudden. Okay, so here is the final task. I need to evaluate this integral. And I'm sure it's related to this part. So what I'm going to do is, we'll notice that these have a common factor of root x squared plus x. So I'm going to split this off from the 5. And then I'm going to factor out the negative. Factor it out. And then what am I left with? X over 2. Oh, and actually let's factor out the square root x part too. And then I'm going to factor this out. So factor. It's galaxy. I don't use it to teach because it's too distracting, especially for younger students. Okay, and then we're almost there. So this part of the integral, you're going to need to use part A. Now notice that it's 2x plus 1, and we have, x over 2 plus 1/4. But this is basically exactly the same. We just need to factor out that 1/4. So if I take the integral of 5, this is going to become 5x, evaluated at 2 and 0. And then I subtract. Now if I factor out that 1/4, Then I get the 2x plus 1. And we already know what this integral is from part A. So we just have 10 from this part, and then we subtract 1/4, and that is 1/4 of our original function right here, y. Evaluated at 2 and 0. Galaxy's nice. It's just not nice if you don't have a continuous stroke, because the galaxy color doesn't flow between strokes, it resets. So if you write in cursive, it'll look nice. So like something. If you write in cursive, it'll look nice. I don't know. I was trying to think of a fancy capital G, but I couldn't. How do you do that? How do you do what? Write cursive? I don't know. What's a good capital G? Cursive capital G. Yeah, I don't know. Yeah, or you can just like, you know, you can see there's also a rainbow color, which is like similar property. I don't like my R's. I need to find a nice capital handwriting R. Mathematical G? Which one's that one? Is it like this one or something? Or is it just like boldface? That's not bad. This one looks pretty good. Rainbow. Oh, tell me about it. I have one student that insists on writing narrow, slanted cursive, and it bothers me to no end every time I read their work. Oh my god, why do you do this to me? Like they write like this. I don't even know if I can replicate it properly. Like, no, it's worse than this. It's bad. Vincent can attest to it. It's tall. Each letter is tall. They're narrow, and then they're slanted, and it's cursive. Why do they do this to me? They really are the worst. Yeah, I can't even replicate it. It's so bad. Anyways, what was I doing? Okay, I multiply these. This is 1/6. And then I still need to evaluate this integral. The 0, 1 is going to just be all 0, and then I just plug in 2. So 10 minus 6. And then 2 to the power 2 is 4, plus another 2 is 6. So this is just 6 to the power 3 over 2. So this is 10. And then this is essentially 6 to the power of negative 1 right here. Then we can combine these two exponents together into 1/2. So 10 minus root 6 is the answer. Okay, you say math is fine because it's all numbers, but the numbers look like that too. I don't know. Long and lanky and curvy and narrow and close together. Like, it's fine if it's long and lanky and cursive if it was spaced nicely, but it's not. Oof. Well, aside from that one terrible question, the rest were not bad. So I'm gonna check my answers. Now I can't show you the answers again because I don't want you to see this website. So I'm just gonna tell you if I got it right. 14 is correct. 3 over 5 is correct. Root 32 is correct. The Venn diagram. 0.4 is correct. 0.8 is correct. 0.4 is correct. And then 2/3 is correct. Okay, and then this one here. What did they want me to do? A is 2, that's obvious. And then 1 minus 18x plus 135x squared, so this is correct. So looking good. And then the next one was this integral one. So this is correct. And then what happened here? Oh, I messed up, my bad. Oh, I got lazy. I shouldn't have copied this. This should have been the 3x squared plus 1. So that these numbers would have been different. Because you're plugging in 4 here. So if you had done that properly, you would get 49 and 4, I think. Which, you know, you can further calculate out and get 10. That's what you get for being lazy. How could you think it's Vincent's writing? His is bad, but it's not that bad. Okay, and then let's see. F of 1 is 0. I have that right here. F of negative 2 is negative 3. A is 2. The domain is negative 5 to 4, and then negative 15 to 12. So that's good. And then this was the beast of the question, which I had to check the answer key. Not because I didn't know how to do it, but every step of the way I was like, is this really how far they're taking it? But yeah, it's pi over 4. LaTeX? I hate using LaTeX. I would rather just manually write my assignments, which is what I've been doing. Okay, the mean is 5.6, the median's 5.8, the lower boundary of an outlier is 2, so that's good. The interquartile range is 2 as well, so these are both 2. The other 20 walk 34 kilometers total. If you combine the two groups together, they have an average of 3 kilometers. And then the new variance is 4, so that looks good. And then I think I checked the mark scheme for this one, so up to here. So I know that this is right, root 16 over 3. And then, oh yeah, and then you just need to show this, and then you do the discriminant, and k is 8, so that's good too. LaTeX? LaTeX is just, it's like a coding language that's meant for like typing out nice math equations. So it's like a better version of the formula tool in Microsoft Word. I don't care how it's pronounced. LaTeX? Who said that? It's spelled latex. Who pronounces X's like K's? Everyone? No one says latex. It's spelled latex. So why wouldn't you say it like the word latex? Okay, and then let's see. So this is the derivative, and then that means that this is the integral. Oh, whoops! I forgot a plus c. That's a really bad mistake for me to do. Don't forget your plus c's when you do an indefinite integral. And then, oh, they actually wanted me to say this for the expression, so that's good. And then 10 root 6. So very nice. Very good. Look, it's spelled latex. I'm going to say latex. I don't care what the creator says, okay? You know, the creator of GIFs say that it should be pronounced GIF, which makes no sense. I don't know people that reference latex in general. I've only ever seen it in written online. No, like who in their right mind has the word latex come up in common conversation besides mathematicians? I've literally never said that word out loud in the context of the math programming stuff. Yeah, well, you know, I have Greek people say that this should be pronounced phi and not phi. And those same people also say that this should be pronounced p and not pi. So, but they're Greek, so I don't know. Yeah, but you see, I'm not in academia like you are. They call it phi. Some people pronounce it phi. I mean, it's quote unquote spelled like this. But yeah, I know a Greek mathematician that says that it's phi, but he also says that this should be p. So I don't know. I will allow that word. Pi pi. Europeans, you think they're more cultured than us? Okay. What should I do? I might just call it a night because I started late. And my students who should be studying are being too distracted by me right now. So I think that's the best choice. Okay, you guys talk about glucose. You can stay in the chat if you want to. I'm gonna sign off. Don't stay up too late studying. You're gonna have me tomorrow morning if you decide to come, and you can study then if you have a bio test. If you see me in the afternoon, well, then you're done and you can relax. And then RGPT is a cultured man cultured Albertan man, because they have lots of culture in Alberta. Learning from his European supervisors. Kiwi Gamer, hello. Oh, you have a question? Okay, what's up? Just coming in right at the end. Yeah, the flattest place in whatever. How do you prove that the limit as x to the power of x as x goes to 0 is 1? That is a question that I think RGBT has more expertise in helping explain to you, dear Kiwi Gamer. Are you on the Discord? You should ask him that there, and then he can help you out there. Do you have Discord? You should get it, and then join this. And then there's a math questions channel. You can post it there. And then RGPT, like I said, has probably a better expertise in explaining why the limit as x goes to 0 of x to the power of x is 1. Anyways, what did you do, RGPT? You posted a Fourier analysis PDF? Gross. You know, the final question of my final assignment of my real analysis 2 was about Fourier analysis, and then you know that thing you're complaining about the Salinger's property and the thing that was trivial? I had to show that in my homework. It's kind of funny. What did they ask about Fourier analysis? They were just kind of going through the steps of that thingy that you sent. You don't believe it? Here, I'll post it later. It's in my other account. But either way, yeah, Kiwi Gamer, go join the Discord. Go post that question in there. and RGPT can help you out. Otherwise, I'm signing off for today because, I gotta let my students who are procrastinating by watching the stream actually study. So have a good night. Don't stay up too late. Sorry, Kiwi Gamer, but, RGPT can definitely help you out with that. Goodbye, goodbye, goodbye.